Hello students, my name is Simantri Sharma, Faculty of Computer Science, Dorong College. Today I am going to discuss about the topic relationships in DBMS, which is one of the topic of DBMS, that is Database Management System. Before proceeding to the topic, first of all you have to know that what is DBMS. So shortly, DBMS is a software where we can store any type of records and to create and manage the database. What a relationship in DBMS? Relationship in DBMS is basically how two or more datasets are connected to one another. For example, if we take two entities such as teacher and student. Now, by taking an example as teacher, by taking a rectangular box which is represented as entity, and in between I am making the diamond shape which is represented as the relationship between them, and the other rectangular box as student. In this example here, teacher and student are two entities which are connected to one another. By this diamond shape we can show that they are related to each other. We can also take one other example as customer and account. If a customer opens an account in any bank, then they are related to one another, means they are connected to one another. Now, next, the different types of relationships. Different types of relationships are one-to-one relationship, other is one-to-many relationship, which is also we can take as many-to-one relationship, and the last one is many-to-many relationship. Next is one-to-one relationship. In one-to-one relationship between two tables, that is, a single row of the first table can only be related to one and only records of a second table, as well as the row of a second table can also be related to any one row of the first table. By giving an example, person has Aadhaar. So, we all know that Aadhaar is the unique identification number for every Indian individual. In the Aadhaar card, we have seen that the 12-digit identity number is the unique number for every person. So, this example can be identified as one-to-one relationship. One-to-one relationship is represented as 1-to-1. So here 1 and 1, this is representing the one-to-one relationship. So next is one-to-many or many-to-one relationship. In one-to-many relationship, any single row of the first table can be related to one or more rows of the second table. But the rows of the second tables can only relate to the only row in the first table. By giving an example as customer has accounts, it shows that the customer can have more than one account. This is considered as one-to-many relationship. But if we consider many-to-one relationship, then each account is held by only one customer. One-to-many relationship is represented by 1:n, and if we represent many-to-one relationship, then it can be considered as n:1. So this is one-to-many or many-to-one relationship. In many-to-many relationship, each record of the first table can relate to any row of the second table, as well as the second table can also relate to any rows of the first table. So by giving an example as there are two entity types, customer and product. It says that customer can buy more than one product, and also many products can be bought by many different customers. So this example is considered as many-to-many relationship. In many-to-many relationship, it is represented by m:n or n:n. Next is participation constraints. Participation constraints means the relationship might be between two powerful entities or strong entities and a weak entity. Simply, a strong entity means it will always have a primary key, but in a weak entity, it does not have any primary key. So, there are two types of constraints, partial participation and the total participation. First, partial participation means that each entity in the entity set may or may not participate in the relationship instance of the relationship set. Here, in this given example, the single line between the relationship and the entity is a partial participation, which means we have seen or we know that if we go for some courses to take admission in some institution, the institution may not provide some courses where enrollments are not made. That is, enrollments are optional. The second one is total participation. The total participation specifies that each entity present in the entity set must mandatorily participate in at least one relationship instance of that relationship set. Here, the double line shows the total participation. In this example, student enrolled in courses. Student is the entity and enrolled in is the relationship. The double line between this entity set and relationship is considered as total participation. Here, if we go to take an admission that we must be enrolled in one course, so this is called as total participation. Therefore, this is the end of my slide of relationships of DBMS. This will help you while making ER diagram, that is entity relationship diagram, to show the relationships of the entity sets. Thank you.